Hello, this is Joe Trout from the physics program at Stockton University. And this video explains how to complete your final project. In your final project, you will look at the climate and weather from two locations that are assigned to you. Weather is defined as the state of the atmosphere at a specified time and specified location, and it's described by the temperature, surface pressure, humidity, precipitation, cloudiness, wind speed, and wind direction. Climate is the weather at a specific location averaged over a specified time period, along with the extreme values. In your final project, you will just look at the temperature signal of the climate. So you're going to look at the average temperature and the maximum and minimum temperatures at your locations. On the screen is 4 years of monthly temperature data for a location, Kanazawa, Japan. If you notice, each year it gets cold in the winter. These are the months January and February. And it gets hot in the summer, which is in July and August. Japan's in the northern hemisphere, so it has a temperature pattern much like ours. It gets cold in the winter. In the spring, it begins to warm up. It gets hot in the summer. It cools off in the fall. Goes to winter, back to summer, back to winter. And although there are variations, each year we could roughly predict what the temperature would be. For instance, in July and August, the temperature is between 25 and 30 degrees Celsius. And in the winter, it's between 0 degrees and 5 degrees. And it seems to repeat year after year in a similar fashion. The specific weather is usually a little difficult to predict. We can tell you that it will probably rain, but we can't tell you exactly when it will start or exactly how much rain there will be. The average weather, at least the temperature and precipitation, is a little easier. For instance, in New Jersey, we assume that the springs are going to be wet, and the summers are going to be hot, and the winters are going to be cold. And we can roughly tell you what the temperature will be in the summer and what will be in the winter. For your final project, you'll investigate the climate and climate trends of two locations assigned to you. You'll be given a spreadsheet containing the location information and approximately 100 years of temperature data. It will also contain precipitation data, but you will use only the temperature data. The files assigned to you are in a file named Final Project Data Files Assignment in the folder named Syllabus and Files on Blackboard. The data files you will use are in a file named Final Project Data Files. For example, if you open the Final Project Data Files assignment, you will find two numbers next to your name. If one of the numbers next to your name is 20, for example, then you will use file 20.xls. So step 1 for your project. Open the file and find your location. Place a map of your location in your paper, and give a short introduction of the geography and climate of the location as found on the internet. You may also add some information such as what their major industry is, and what the population of the location is. Step 2, you will make a graph of the 30-year monthly average temperature, the 30-year maximum temperature, and the 30-year minimum temperature of your location as a function of month. This defines the temperature component of the climate. So as we said, if we look at 4 years of temperature data in Japan, what we see is that there's a signal and you can pretty much predict what's going to happen the next year. What you will do is average these temperatures over 30 years, which is what the United States uses for the time period for determining the climate. Your graph that you will put in your paper should look something like this. And I'm going to show you how to make this graph. What we see is the blue line is the climate. And each point, for instance in January, we took 30 January average temperatures and averaged them over 30 years. The same thing for February and March and April and August. You will plot this average temperature, the blue line, versus month. So it starts at 1 and it ends at 12. Also find the minimum temperature over that 30-year period and plot it versus month. And the same thing for the maximum temperature. So you should put this graph in your paper and describe it. So say that the climate in Japan is coldest in the months of January and February, and the average temperature is somewhere around 2.5, and you can read it off your graph. The hottest temperature is in July and August, and it's about 27 degrees Celsius. And then describe the minimum and the maximum, the extreme temperatures that have been seen in those 30-year periods. So for instance, in August, the average temperature is about 27 degrees, and the maximum that has been seen is about 30 degrees, and the minimum is about 25 degrees. Step 3 is to see how the climate is changing, or if there is any trends to the climate. So what we'll do is we'll average the 12 months for a given year. So we'll find the yearly average. We'll also look for the yearly maximum and the yearly minimum temperature. And we'll make a graph of the average temperature, that's the red line, the minimum temperature, which is the blue line, or the blue markers, and the maximum temperature, which is the green markers. We'll also do a linear trend analysis. So this is just a line, right? Y equals the slope times x plus the y-intercept. And this slope here tells you how the temperature is changing. So for instance, in Japan, it looks like every year the temperature is increasing 0.0107 degrees Celsius. So every year the temperature will increase by that. If the points all fall on exactly the line you made, then R square value will be 1. The R square value tells you how much variation there is around your linear fit. So if it's perfect, it'll be R squared will be equal to 1. You can see here R squared is a very small value, which tells you there's a lot of variation. However, the linear trend shows that about 0.0107 degrees Celsius, the temperature increases each year. So this is for the maximum temperature, this is for the average temperature, and this is for the minimum temperature. So the average temperature is increasing 0.0098 degrees Celsius each year. The maximum temperature is 0.0107 degrees Celsius each year. And the minimum temperature is increasing by about 0.005 degrees Celsius each year. Step 4 is to take these linear trend approximations and make the linear trend approximations. In step 5, you'll summarize your results, and step 6 is to repeat this for your second location. So now let's go ahead and describe how to do this exactly. First, go ahead and open up a Word document. Next, go to Blackboard, and under Syllabus and Files, you'll find the Final Project Data File Assignment. Next to your name, you'll see 2 numbers. Let's say one of those numbers is 20. Go to the Final Project Data Files and find File 20. Depending on how your computer is set up, what you should see is once you click on it, it should open that spreadsheet file for you. You may see it appear down here, and if you click on it, it will open up the file. The very first thing to do is to enable the editing by clicking on the Enable Editing button. And then save the file so any changes you make can be saved to your computer. Either save it to your own computer, or if you're using a computer on campus, you can save it to a USB drive. I'm on my own computer, so I'm going to save this file. I'm going to save it on the desktop. You can save it wherever you'd like. What I recommend is adding your name to the file. This way, if you have to send the file to me, I know who it's from. I already have a file called that, but I'm going to overwrite it. The next thing to do is to note the location. So this is Kanazawa, Japan, and see what the latitude and longitude are. Go ahead and write down the latitude and longitude. So I'm at 36.58 and 136.63. The first thing you want to do is find your station and put a map of it into your paper. Use your favorite mapping program, but I'm going to use Google Maps. So I'll go to a spreadsheet. Go to a web browser and enter Google Maps. And then open Google Maps. And on the search bar, put the latitude first. So mine's 36.58. And then the longitude, which for me is 136.63. And hit return. Or enter. what you'll see is a street level map. Now that's not going to help you very much in looking at the temperature, or excuse me, at the weather and the climate. So you can go ahead and zoom out on this picture. So you see my location is written here. And if I keep shrinking down, you'll get a map of your location. And note the geography. So for instance, this is right on the coast of the Sea of Japan. And it's on a very narrow island. I think being close to the water will have a big effect on what the weather will be at this location. Just like the Atlantic Ocean has an effect on the weather at our location at Stockton. Go ahead and paste this picture, this map into your paper. Whenever you're given a task to do something on a computer, people can tell you a couple hundred different ways to do it. So I'm going to tell you what I think is the easiest way. There's a tool in Windows, if you look under Windows Accessories, that's called the snipping tool. If you open it, it'll bring up a dialog box, and you can click on New, and it says New Snip, and define the picture you want to be. By the way, if the picture doesn't turn out exactly like you'd like, for instance, there's the word Google down here, and there's some junk here in the lower left-hand corner, so I'm going to do it again. Now you can take this and do Edit Copy, and you can go ahead and paste it into your picture, into your document. So bring up your document, and you can just say paste, and it'll paste the picture into. For your paper, every figure should be numbered and tell what it is. You must have a map of your location inside your paper. Some people also like to show the satellite view. This is good because it shows things like mountain ranges and what the geography looks like a little bit better. Once again, we can use the snipping tool. Just click on the snipping tool and New. And edit and copy. And you can easily paste that into your paper. So this will be figure 2. Next, you'll have a brief discussion or brief description of the location. This will include such things as what the a what you research on the internet tells you about the weather and about the people that live there and about the industries there. This is easy to do. Just go back to your web browser and search for climate and you'll see a bunch of websites come up. So the first one is from Wikipedia, and it tells you the weather is temperate, though rainy. The average temperatures are slightly cooler than those of Tokyo, with approximately 4 degrees C in January and 12 degrees C in April, and 81 or 27 degrees C in August. There may be some better websites to look at, and I wish I could tell you just one location that would tell you all that would, or one website that would show you all of your possible locations, but I can't. So what you could go through is, for instance, climates to travel, right? And it'll tell you something about the city, right? It talks about where it's located, and there's a monsoon circulation that causes some rain, and there's some more information, and you can read this and write a brief description of your location. Once again, you can look at things like the population, how large the population is, and what industries are available there, along with the climate, just to give people an idea of your location. Next, what you're going to do is look at your temperature data and see what you think the climate looks like from the temperature data I provided for you. So go back to your Excel spreadsheet. What you see here is the parameter is temperature, and it gives you the year and the temperature, the average temperature for each month for every year. We're going to go down to the bottom of the temperature data, and just to make things easier to read, I'm going to enlarge everything. You don't have to do this step. I'm just going to do it so that you can see it. So what we need to do is find the monthly average for 30 years of data. So go down to the bottom of the temperature. Note there is also precipitation data. You're not going to need that for this project. Go ahead and add a couple lines in at the bottom. You can do this by clicking on the row number and clicking on Insert. So add about 5 lines. Now under the year, write the word time and month. So we're going to use the time in months. And go ahead and put the months in, 1 through 12. Then we'll have the average temperature in degrees C. and the minimum temperature in degrees C, and the max temperature in degrees C. Note that my last year that I have for this data set is 1990. We want 30 years of data. So we're going to find the average from 1960 to 1990. That'll be 30 years. There's a function in Excel called average, as you learned from doing your spreadsheet worksheets. And you can say equals average, open parentheses, click on 1990, and then highlight by holding the mouse down to 1960. And close the parentheses. Now we need to do that for each month. If you click on the box, you'll notice a little box down here. This is the edit fill box. And if you notice, when you bring the cursor over the box, it changes from a fat plus sign to a thin plus sign. Once it's in the thin plus sign, click on your mouse button and drag it over to the other side. And now you'll have the monthly temperature data for months 1 through 12. Now we need the maximum and minimum temperature. We could search through and find what the maximum and minimum temperature are, but Excel also has a function called minimum. It's abbreviated by MIN. Click on the temperature for 1990, highlight up to 1960, and close the parentheses. And you can do the same thing for maximum. There's a function called max, and we'll highlight the temperature in 1990 to 1960, and now we have the maximum temperature for the month of January. You can highlight these two boxes and use the edit fill box to find the temperature. Now we need to draw the graph. Highlight all of the data, so the time, the average temperature, the min temperature, and the max temperature. Just in case you're not very good with spreadsheets, to highlight, just click on the month, hold the mouse button down, and drag it around until you highlight everything. Don't forget, if you ever make a mistake, there's an undo radio button up here. You can undo whatever you have to undo. Now we're going to insert a chart. Go to Insert, Chart, and we'll use the scatter plot, or the XY chart. And roll data points should be in points, okay, but we just took an average, so we're going to use the smooth lines scatter plot. I'm going to move it around and enlarge it so you can see it. And for a chart title, you want to put your location. Note there's no axis labels, so nobody knows what you're talking about. We're going to have to insert those axis labels. When your chart is selected, you should see two tabs up here, Design and Format. If you click on Design and add Chart Element and Axis Titles, And you can click on primary horizontal axis, and that'll give you your x-axis. In this case, our x-axis is actually time, and the units are a month. You can format this title, make it a little larger, for instance, so you could see it. The same thing with the title of the graph. If you want to do some formatting, you can change it a little bit and make it a little larger or whatever you'd like. Now that tells us what our x-axis is. We need to put in our y-axis. So click on Design, Add Chart Elements, Axis Titles, Primary Vertical, and this is temperature in degrees Celsius. Let's go ahead and make it a little bit bigger so you can see it. Also, you should format it so that it's accurate, right? So if you format the degree sign and click with your right-handed mouse button, you can go to Font and make it a superscript. So this is what your chart should look like. And what you're going to do is describe what this looks like in your paper. We'll go ahead and cut and copy and paste this into our paper. So we'll click on it, go up to Home, and copy. Or a shorthand version is just to click on it and click with your right hand mouse button. A menu box will come up. You can hit copy and we'll paste it into our document. You can resize it if you'd like and change the format a little bit. Don't forget to label it. This is my third figure. And then go ahead and describe what the temperature climate is for your location. So going back to the spreadsheet, we see that in the winter, the average temperature is about 3.4 degrees C. So that's in January. And then it reaches its maximum temperature in August at about 27 degrees. The minimum temperature recorded in January for the 30-year period is about 1.2 degrees C. And in the summer, the maximum temperature reached about 24.9 degrees C. I'm sorry, they're the minimum temperatures. And for the maximum temperature for January is about 6.2 degrees C. And for August, it reached a maximum of about 29.3 degrees. So go ahead in your paper and describe what this graph looks like. And also see if it matches the data that you found on the internet. For instance, what they said the average temperature was in the winter and the summer. I'm going to go ahead and move this graph out of the way on my spreadsheet. You could just click on it and drag it out of the way. Don't forget to save often. So we'll go ahead and File and Save, and it'll save that file for us. Next, we want to see if the climate's changing. So this tells us the climate, the temperature data for the climate, that graph we just made. And now we want to see if the climate is changing. So what we'll go ahead and do is look at the average yearly temperature. I'm going to go ahead and readjust my cells so we can see it. The yearly max temperature. And the yearly min temperature. Now we want the average over the year, so we'll hit equals average and highlight the temperatures for that year. We'll also find the maximum temperature for the year. Once again, we could look through. It should be 27.5 degrees, but you don't want to have to look every year and type it in, so we'll just use the function and have it find it for us. And sure enough, it's 27.5. The same thing for the minimum. So once again, what we'll do is hit equals the function name, so in this case it's average, and then click on the first temperature, hold the mouse button, and drag it over to the December temperature. Close the parentheses and hit enter. Sorry, in case a couple of times you may hear me say return instead of enter. Old keyboards used to have both return and enter written on it, but if I say return, it really means enter. Go ahead and highlight these three cells, and you can use the edit fill down box to fill down for each column. And go down to your last data set. We're in the process of updating the data sets. Most of yours will end in about 1990. Now we need a graph of these three temperatures, the average temperature, the maximum temperature, and the minimum temperature, as a function of year. So what we'll do is click on the word year and hold the mouse button down till you get to the very last year. Then hit the control key, that's CTRL key, release the mouse button, and go up to these columns you have labeled, and holding the control key down the whole time, just go ahead and highlight the temperature data. So once again, that's click on year, hold the mouse button down, drag down to the last year, which in my case is 1990, press the control key, release the mouse button, go up to the temperature, while holding the control key down, click on the average temperature, and highlight all those three, holding the control key down the whole time. Now go to Insert, Scatter Plot, and it makes your plot for you. You can go ahead and resize it by grabbing one of the quarters that's clicking on it and dragging it. First thing to do is change the chart title. You might want to reformat it, so make it bold and larger, for instance. Okay. I'm just resizing my spreadsheet so you can see it. Go to Design tab. Don't forget, the Design tab only shows up if the graph is highlighted, and you highlight the graph by clicking on it. Go to Design, Add Chart Elements, Axis Titles, Primary Vertical, Axis Titles, Primary Horizontal. Once again, our x-axis is time, but this time is going to have units of year. You can go ahead and reformat it if you'd like. And sorry, I'm doing this live, so if I click a couple times, it's just trying to highlight things. This will be temperature in degrees C. Once again, it should be a label, and then the unit should be in a parentheses. We can highlight that and make it bold and larger. And don't forget to format it correctly. So this should be superscripted, so click on it, font, and superscript, and it'll look something like this. Now we need to find a linear trend. This is how you do that. Click on one of the data points. So for instance, in the maximum temperature, I could know this is the maximum because it's the largest temperature, right? Click on it. And then with the opposite mouse, with the right-hand mouse button, click on that. And then add trend line. And we're going to make it linear. And then if you go to the bottom of that screen, click on Display Equation Chart and display our squared value. Move the equation by clicking on it to move it to somewhere you can see it. You can also reformat that. So this is A minus work right now. To make it A work, what you want to do is change these labels. So this isn't really Y versus X. It's temperature versus time. You should also change the units. So it should be degrees C per year. And of course, this should be superscripted. And the y-intercept is also degrees C per year. Is also degrees C, excuse me. What this tells me is that each year it looks like the temperature is increasing 0.0107 degrees each year for the time period we have selected. That's that 30 years ending in 1990. Just so you know, this would be the temperature at year 0. So this would be the maximum temperature at year 0. However, it doesn't really make sense because this is assuming that this linear trend continued back 2,000 years. It probably didn't. So this doesn't really tell us anything. However, the slope of this graph does tell us how the maximum temperature is increasing. We'll do the same thing for average. So we'll see if there's a linear trend. We'll click on one of the data points. Then click with the right-handed mouse button. Add trend line. The default is linear. If linear isn't clicked, go ahead and highlight and click on linear. Go to the bottom, display equation on chart, and display R² value. Move the equation so you can see it. And you can reformat it if you'd like. These should both be of the same font size and font style. So this is 18. We'll make sure that this one's also 18, and it is. Once again, this is temperature as a function of not x, but time. So physicists use a capital T for temperature and a lowercase t for time. And it's degrees C per year. And this is degrees C. And of course, degrees should be superscripted. Sorry, I just hit subscript by accident. Superscript. Okay, and the same with this one. So it looks like the average temperature in Japan is increasing 0.0098 degrees C each year. Note that if this was a negative value, so if this really said negative 0.098, that would mean that the average temperature was decreasing each year by that amount. Note that the average temperature seems to lie pretty well in that straight line, and we get a R² value of 0.29. There's a little more variation around the line for the maximum temperature, and the R² value is smaller. If all of these points lied exactly on that dotted straight line that Excel drew for you, then R² would be 1. So R² tells you about the variation. Finally, we'll do the minimum temperature. Click on one of the data points. and you'll see that it picked this all the data. Use the right hand mouse button, add trend line, linear, display equation, and display r squared value. Move the equation so you can see it. Reformat it if you'd like to the same size as the other two. You can make it bold if you'd like. And don't forget, this is temperature, capital T, versus time. And the units are degrees C per year. And the y-intercept is degrees C. And the degrees should be superscripted. So this is an A+ graph. This is perfect. Go ahead and copy it and paste it into your paper. Occasionally, things will get a little weird. If you resize the paper, if you resize the graph, it will look a little bit better. Maybe you think that now this is too big, so you can shrink them a little bit. Oops, went the wrong way. Make sure they're all the same size. And I'm sure you know, but I forgot to say, make sure you go ahead and save this. So once again, I'm on my home computer, so I'm just going to call it Final Paper, Joe Trout. So don't forget to save often as you're doing this. All right? Then in your paper, you'll go ahead and describe this graph and say that you found that the average temperature was pretty linear. It fell along a straight line. And at least approximately, it looks like the temperature is increasing 0.005 degrees C per year. And go ahead and say that for each one of these. I'm sorry, that was the minimum temperature. Go ahead and do that for each one of these graphs. And then write a brief summary about what you found. And then repeat these steps for your second file. Don't be afraid to ask me questions. If you're having trouble with your data sheet, if you send me a copy, I can look at it and see what I think is wrong. Okay, I hope this was helpful. And of course, there's an instruction sheet on exactly what to do for your paper along with a rubric of how the type paper will be graded. And they'll be located on Blackboard. Right? Thank you for your time.